Yo, what it do, everybody? We're back in the part 2 of this kata. I have cleared the space, so now we can film for as long as we want. Ain't that nice? Alright, so the last time we found this neat little video, which would be maybe to just watch, and we still are reading this Wikipedia. So this thing and this thing produce this, which maybe produce our solution. Here's some other theory on FSMs. But let us just watch this video. I hope Barry Brown won't be angry at us. Yeah, Barry. Let's see, maybe, or what if his videos are, he's a professor, Sacramento, Sierra College. Maybe his videos are really bad, I don't know, let's see, let's comment it. I think it will be a commercial nevertheless. I mean, nobody's gonna watch this video anyway, so it doesn't really matter.
So you've been given the problem of converting a regular expression to a finite state automaton or a finite state machine.
Yes. Right here. Oh my god. Oh my god. We have been thrown out. Oh no. Alright.
And what I'm going to show you in this video is how to do it kind of the organic, holistic way. A little bit later I'm going to show you how to do it using an algorithm, which is a way that a computer might do it. But this is sort of the way that a human might do it. So let's say the regular expression you need to convert is A, B star A. And this means you need to accept an A, followed by a 0 or more B's, followed by an A. So a couple example strings that you might recognize by this would be A by itself, because we can have 0 B's.
Okay.
Then we can have A, B, A.
And then ABBA. Yeah, like the music
A,
group.
B,
3 B's.
B,
Yeah.
B, A, and so forth.
8 B's.
So before we actually convert this to a series of states and edges, let's go over some of the general rules that you need to be able to convert this.
Yeah, do that.
So you need to know 3 things. First of all is that if you have a regular expression x or a regular expression y.
Yeah, that's what happened over here, you know. We have regular expression this or regular expression this.
Into edges and states, or a regular expression y, you can convert that into edges and states by drawing 2 states and 2 arrows going between them and labeling one of them x and one of them y.
Oh, okay.
And then if you have a regular expression x followed immediately by a regular expression y, you do that with generally 3 states.
What?
2 arrows between them.
It's first
and
x,
the
then y.
and the second one y.
Alright, so the thing that we are making with regular expressions in finite state machine is basically doing these actions, but from where to where?
And then finally, if you have a regular expression x star, you can represent that with a state and an edge going back to itself and labeling that edge x.
Okay.
So let's go back to our example here of A, B star A. We see here that we've got basically 3 pieces. We've got A, B star, and A. So we can convert that by drawing our first edge going from the first to second, labeling that A, second one labeling that A as well, and then the third one here in the middle is the B. The one on the left here is our starting state, so we'll draw an arrow going into it, and the last one is our accepting state, and we'll represent that with a double circle. So we can see that this...
okay, wow. Right now I'm thinking, how could I apply any of these models of over here, where you got a state, something in between, and another state, or a starting state, or what the dude said,
accepting state.
Accepting state, you know. Apply this to this. You could say starting state would be number, and then accepting state would be true or false.
That with a double circle. So we can see that this works.
Yo, this is also over here, write this expression. And this is just regular expressions, but this finite state automation is shown over here.
For our examples, let's try the first one here, which is AA. We start here at the starting state. We follow one edge and get an A, and then follow another edge and get the final A, and we end up in our accepting state, which means this string is accepted by this finite state machine.
Yeah.
Let's try the second one, where we have a BA. We start here at our starting state. We follow the first edge for an A, then we follow the loop for a B, and we follow the next edge for an A. We end up in our final accepting state, which means this string works as well.
Yeah.
And then we'll do a BBA, so we start at the first one, follow the edge, follow the loop twice for the two B's, and then follow the A again and end up in the final state. So this one works. And it works as well for the last one with 4 B's in a row. Let's do another example. Let's say we have to do A or B.
Okay.
Followed by C, and I got the parentheses here, meaning that this goes as a group.
Also, this means chuck, A, B, and there is a third state, and only C leads to the third state, which is accepting state.
So a couple example strings would be, let's see, actually there's only 2 here.
Like that's what bothers me, is because I know what this will look like. Because there is such a low learning curve from one example to another represented over here. But there's still a huge gap between the theory and the application on a real problem. Because this is just a demonstrative problem. If we could maybe take this problem and this problem as the same, no, we can't take them as the same. Or maybe we can, if this 0 and this are 2, because OR is here in between, are 2 like arrows to somewhere. They
can only be A, C, or B, C. Those are the only 2 strings that this regular expression accepts. So converting this, we're going to do the A or B, which we can represent using our first rule up here. 2 states, an edge, 2 edges between them, one labeled A, one labeled B, and then a third accepting state with an edge going labeled C, and the one on the left here is our starting state. So we'll see that this works here. We'll try the AC first. So we started our starting state. We follow the edge for A, and then follow the next edge for C. We end up in our accepting state. So this one works. And then likewise for BC, we just follow the bottom edge down here, and then C. So we know that that one works as well. And let's do a third example, which is, let's say we have the regular expression A, B, C, star, and I grouped the B and C together, meaning those have to go as units. So we got 0 or more.
Hey, sorry guys, I just realized I'm not fair to this dude called Barry Brown over here. Because I said, oh, how is this gonna help me with this? Oh, poor rock. But the thing is that the name of the video says convert regular expression to finite state automation. And it does just that, you know. If finite state automation means drawing these diagrams, then the dude nailed it, you know. Because like have 1 minute ago I just like said that, oh, this is with or in between looks like starting state, here is 0, and bottom state is like everything over here. This is the finite, like the accepting state. So this dude did just that, as it said in the title. So at this point I'll acknowledge and leave this dude a like. I need to sign in over here in Brave. Well, let's copy, go to Chromium, let's go to this video over here.
So you've been given the problem of converting a regular expression to a finite state automaton or a finite state machine. And what I'm going to show you in this video is how to do pairs of
double knowledge, you know.
Meaning a little bit later I'm going to show you how to do an algorithm.
Alright,
which is the way that a computer might do it. But this is sort of the way that a human might do it. Or more pairs of BC.
Oh.
So let's do some samples.
Oh, what the hell? Is that just like A and then BC like looping?
Strings there. So that would be A by itself would work because we can do BC, just 0 of them. We can do A, B, C, which is one pair of BC.
Or A, B, C, B, C, B, C.
B, C,
B, C. Do another one, do another one. Oh, come on. C, B, C, B, C.
You get the picture there.
Yeah.
I can just repeat infinitely. So let's convert that one. We have, let's see, well, so the first thing we need to do is we need to do the A. So here's our starting state.
Yeah.
And we're going to do the
That's just the
here.
A, and they're only.
And then what do we do about the BC? Well,
Yeah, it's the only one, right? And it just says BC inside. There are not 2 loops, only 1 loop, and it has a BC on them.
BC is done with a loop, but we need to incorporate into that loop the fact that we've got 2 edges to follow. We got that BC.
Yeah.
So basically, we need to do a loop combined with this a chain of.
Whoa, you for real?
We'll do that like this.
Wow.
B
Wow.
and one of them C, and this
No
one here will be our
way.
accepting state. So let's see which ones.
Alright, this
work.
complicates
We'll try
things
by
a little
itself.
bit.
So we start at the starting
Damn.
state. We follow one edge, and look, we've ended up in our accepting state. So we know that A works. Let's try A, B, C. So we started our starting state, and then we follow one edge to B, and then follow another edge up through C, and we end up in an
Okay,
accepting state.
because you
So
cannot. Yeah, I mean, alright, because there is no way you'll finish over here, because you cannot just finish here in the middle, because in this case B always follows C.
Works. And then A, B, C, B, C, we'll start at our starting state. We'll do A, B, C,
Yeah.
B, C, and that one works. And then the last one, of course, is just looping that B, C one more time. We'll do A, B, C, B, C, B, and C, and so that one works.
Alright, thank you, dude. Nice. Let's watch the second part.
In this video, we're going to do a
I don't know, do you think we shall like this one or not? We shall see.
couple more problems where we're converting simple regular expressions to finite state automatons. And the regular expressions we're going to do in this video are a little more complicated than in the previous one. The one we're going to start out with
Yeah,
is
thank
A,
God.
B,
Thank God. Guiding our direction.
C star or J plus K. Now, there's a couple things to illustrate here. First of all,
Alright, I'll try to learn right here, right now. So we'll go in that sketch pad. What's with these two dudes like selling me stuff? Like, what's the point of making like this super new browser that's like saving my stuff, but it's still selling stuff right over here? I don't know, like, come on, I'll just make my own browser, you know. Sketchpad. Alright. Hello, welcome to your digital main makerspace. So if we have it ABC star, so we not calligraphy, let's use pen. So we see A B C star. Alright, and then this, and then J plus K. Alright, so I understand it like this. You start with, this is a starting state, and here's an A, or no, this is just the starting state, and it goes with A to here, and we started here, now we're here, and now we go with B to the next state. Also, regular expressions are in relation to finite state machines. Regular expression is a finite state machine. And right now there can be, this means it can be 0 or more C's, and this means that, check, and this is a C. Now it can be this, or yeah, I may have committed some logical fallacies over here, but if it is, I don't know, this, I mean, Barry didn't use any of the braces or brackets, you know, so right now I can translate this like, so only this is concerned regarding this OR sign. So if you do it like that, it's either from here, either C that does nothing, or either J that is at least one or multiple times. So that leads us, if you go from here to here, this happens. If you go from here to here, then so one or multiple times. So then it can maybe happen a bunch of other stuff, like an infinite number of states can happen after that. But we know, so at least it happens at least, so it's either C, from B to either C, or because if we say B, it's right here, and from here it can be also with J, and it's at least once, but if it happens multiple times, it is just the same. And then there's K in the end. Let us see, because right now I'm just following the exercise. I don't really know what I'm doing, but it's starting to dawn on me that with this finite state machine you could maybe in a certain way interpret what regular expressions are doing.
This OR here, actually, although it's listed first in our list of rules here, it actually has the lowest precedence, meaning this is interpreted as A, B, C star, or J plus K. So it's not A, B, and then C star or J, and then plus K.
Yeah, that's what I thought. Where I thought C star or J plus, because in regular expressions it's J plus, not the J plus K, because this plus only relates to the preceding character.
C star on the left, and then J plus K on the right, and then that whole thing as an alternate. Now, there's a couple of things to show you here. First of all, we haven't seen this plus yet, and the plus is kind of an extended notation in regular expressions. It's not part of our three rules. In fact, these three rules are all you really get for regular expressions. Let's review those three before we add on the plus.
All right.
So the first rule is if we have a regular expression x or y.
Okay, yeah, I understood. I had this like I did on this with plus, because at least one happens, and if it happens multiple times, it happens multiple times. But yeah, I guess plus is a special example because yeah.
Okay. Then we get this two states with two sets of edges going between them, where we can make a choice between going x or y. And then we have x followed by y, which is represented with three states. We go x and then to y.
Yeah, we know
and then
that.
finally
We know
x star,
that.
which is represented with a state with a loop on it.
Yeah,
with the
we
x,
know
and
that,
we
man.
can kind of repeat that loop as many times as
We
we need.
know that, man.
So we'll add to this our another rule here that says anytime we have a regular expression with a plus, that's actually the same as x star.
I fucking knew it, man. I fucking knew it. That's what I did. Oh my god. Yo, I fucking did that, man. Look over here. I fucking did. Oh my god. That's so nice. That's so nice. But the thing is, I didn't thought of it that way. I just drawn it that way, and that's a really nice way to look at it, if you ask me. That's a really dope way to look at it.
Represent it as a state, an edge going from one state to another, and then another one with a loop. So x plus is just saying we need one or more x's, and we can represent that with a mandatory x followed by 0 or more following x's. So let's do our example here. First of all, some possible strings that this could recognize would be, let's say, we could do A, B. That would be sufficient because we can do a C star here. It means 0 or more C's. We could do A, B, C. We could do A, B, C, 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 C. And then on the other side, we can do J, K, because we got one or more J's followed by a K.
Yeah.
And then we can do J, 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 K. There's our one or more J's followed by K. So
this dude wants to say that this thing is actually, I thought it meant something like this. But actually this dude is saying right now that this thing actually looks like this.
5 strings that are possibly going to be accepted by our regular expression. So we'll start with our conversion. Let's see, what can we do first? Let's work on the left-hand side first. Now, another thing is, in our rules, I had said here that if you have an x or a y, then you've got two states with an x or a y, and both x and y go to the same state. There's actually no real reason to do that, especially when you're doing something like this or, where you've got or something on the left, something on the right. This is essentially going to accept two different strings, A, B, C, star, or J plus K, and there's actually no reason why they have to end up in the same place. They could end up in different places as long as we end up in a final state. So I'm going to do this in kind of two phases. So I'm going to start with my initial state, the arrow pointing to it, and then watch what I'm going to do here is I'm going to say this edge over here is A, B, C, star, and this one down here is the J plus K edge, and both of these are going to end up in a accepting state. So if we start here at our starting state on the left and we do an A, B, C star, we end up with an accepting state, which means we've done the left side, or we follow the right hand side and end up in an accepting state down there. So I'm going to now expand out each of these two edges into A, B, C star and J plus K. So let's go down here. Now the first one, we already kind of know how to do that. Here's our starting state, here's our accepting state.
I'm just resting my eyes.
We're going to put one in the middle. The first edge is A. The second one is B, and then here's our loop for C. And just to see if that works, if we do something like A, B, we started our starting state, we go A, B, and we end up in the accepting one. That's good. A, B, C is starting at A, going to B, looping once on the C, and A, B, C, 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 C. Part's going to work, be rewritten. The first edge is J. We'll do a loop for another J, and then finally an accepting state.
What's up? That's what we did, man.
So this says we're going to do J, K, which is this string right here.
I like it.
J, we've got a finite state automaton that has one starting state. Finite state automatons always have just one starting state, but they have two accepting states, and that's perfectly okay. As long as you end up on either one of those accepting states, then we can say that this finite state machine or finite state automaton accepts those strings. Now let's do another example. This one we are going to do the regular expression w, x or y, star z. So this one here, we have an alternate x or y.
Okay.
And that's being repeated 0.
Okay, that's an interesting one. Let's open up a new document and let us say. So we got w, x, this thing, and y, star, star, and z in the end. So we always start in the beginning, and this thing there can be multiple x's that are multiple and multiple multiple y's. Oh, scratch that, oh. So starting state here, we go to the second state with the w. In this state we can do x any number of times and y any number of times, but that always leads to that always leads with z to the accepting state.
More times. So as usual, we'll start out with what are some strings that this accepts. We got wz because we have 0 or more of this thing in the middle.
Yeah.
We have w.
This dude always makes like practical examples of that.
Z. How about wxxz? That should work too, because we can go w and then pick an x.
Yeah, it's oh, no way, man, no way. You sure? Oh, okay. Yeah, okay. I get that, man. I get that. But that's really interesting way. I cannot believe that like he did it for like 3 times now, and now I realize how it's interesting that he first makes practical examples of this.
So
it can really help you get it, you know.
Let's try the first one here, wz.
Yeah.
So
all of them
those work out just fine for that. So to review, we have when we're doing finite state automatons, we always have one starting state. We have one or more accepting states, and then we use one of these 3 rules to determine what the picture is going to look like. And there were also some shortcuts for doing plus, which can be reduced to like x plus, or excuse me, x plus can be reduced to xx star, and there's a way of drawing that.
That's it, I guess. Regular expressions to NFA. Let's just check out this video, but I think that's to NFA, to DFA. Why is here NFA and here DFA? But the computer needs an algorithm. DFA, NFA. What is NFA? NFA. Yo. NFA. Science. Non-deterministic finite automation. Alright. So we learned that. So we must make something like that. That's a little... Oh! And here is the diagram for dividing by 5. Oh my god, but we cannot see it. Alright, now I know how precious this image would be, because that would be so easy. That would make stuff so easy. FSM diagram for dividing by 5. It's right over here. But that's for dividing by 5. If this can be divided by 5, so where's the starting state? I mean, where's the starting state? No, where's the starting state? Like, not here. This is the accepting state. Not here, not here, not here, not here, not here. Maybe you have to reverse engineer it. Like, cause that dude, like our man Barry always made this, you know, in the beginning, to know where to start. But these things do not have a starting point, and that gives me a confused look on my face, you know. And I'm kind of frustrated, man. The link does not work. Let's see the discussion. Let's see. Help please, I'm very confused. Alright, nice. The DFA accepts the empty string. But that's not according to the sample test. Yeah, but this thing don't even show up, man. This picture does not show up. There is an HTML element. There is an image with that points to somewhere else. You copy that and paste it here, but I guess okay, no, this is the same one. Yeah, what's wrong with this image? Why doesn't it load? Oh, maybe because we're on the wrong browser. You got the wrong number, fool. Nah, that's yeah. All right. Okay, it says DFA accepts, yeah. 1Q. I've made a C translation. Is incorrect. Is not accepted. Alright, the people are dissing this one, so I guess that's why the dude removed it. Alright. So I guess that's a kind of a clue. We should find a FSM diagram for dividing by 5. So let's see if there's a video about it. Grade 5. Dividing fractions. 2 divided by 5. Take another look. Alright, so one thing that I want to do to break this chase for this FSM diagram, or also this clue right here. We'll continue by reading this, but right now let's take a break of this hunt and let's look for decimal to, is it called like this? Decimal to binary. Okay, let's see if there is a simple way. 5 is 101. If there's a simple way to notice what is the characteristics of a pattern that accepts numbers that can be divided by 5. So this ends with 101. This thing's 101 0. Alright. 15 is 111. Interesting. So this is 101. No. 25 is 111. And 30. Okay. All kinds of interesting stuff are starting to happen. Alright, but I cannot see any heuristic rule that could help us. So let us see. Mathematics. Why does this finite state machine accept binary numbers divisible by 3? This finite... okay, so one dude is confused. He said, yo, this finite state machine solves a thing, but I don't understand why. This finite state machine accepts binary numbers that are divisible by 3. In theory, the state should equal to the value n modulo 3. Why? The 3 number is... Wow, look. What if I change it? I cannot change it. But how does this work for binary numbers? What I don't get is how the transitions get together, because a new input 0 or 1 doesn't mean that a fixed number is just added to the overall n. Can you please help me understand it? Thanks in advance. But right now I would like to make a pause and I'll come back. It's a pretty hard one. We're doing good. So see you in a bit.